So next one, let's test for remove a function. So let's do the same thing based on the test list generated so far. Let's remove randomly from the given data. So let's have a loop. Let's remove just half of the size. So yes, similarly, every 50 times, you can choose how often you want to do that. So let's remove the very first one. Then from the vector, remove a v. In this vector at position 0, we need to remove that. So let's define remove a v function similar to insert the v. So vector int reference is provided and then position is there. Then we do pretty much the same. So we can erase a vector has an eraser function based on the given iterator. So we need to do exactly the same thing. So here we need to move through the vector using iterator in post time, and then finally you can erase at this iterator position. That's a remove data from the vector. So let's redo that. And then let's remove the one very last. So let's take a look at slist remove function. So we are removing the only data and the very first one, and then between two nodes and the tail node. That's how we implemented the remove function. So we need to test all of those cases. So let's remove the very last one. Test size -1 is the last data. So remove from the vector. Vector has a size function as well. So the very last one remove. And also let's remove a data from random position. So int position random number generator, and then let's take a modulus size. Then the maximum number we get is a size -1. That's a valid index of the list. Then let's remove from position, and then also remove a vector at this position. It's there. Then let's compare those two, list and the vector. 0, test the size, assert, test dot get I should be same as a vector I. So that's what we are expecting. So compile, remove a v. The prototype is not given, so let's copy the header part and parameter name, we don't need it there. So prototype is given, compile and run. Oh, we have an error. So what the error message says, a pointer being freed was not allocated. So in other words, we are freeing something that is not allocated or that was already freed and so on. So there might be some pointer issue. So let's debug this code. So in remover, so let's set a breakpoint, debug, run. So moving one by one may take too long. So let's set a breakpoint, remove here, and do continue. Continue. Okay, here we got an error. Error is deleting tail node. Then error message was free error message was being freed was not. So delete tail is in error. So it seems like the remove function is not correctly implemented. So let's do the debugging a little bit more. So let's have this test remove and then start the debugger. It's there. Current iteration I is 0. It's the very first time entered this one. So continue. Now I is 50. So second time of I modulus 50. And then try to remove a step over, step over, step over. Here we got an error. So the error was when we try to remove from the very last one, we get an error message. So let's check for remove function. So slist remover, this part is in error. So let's go back to the main test. What we tested briefly was something like this. So given data, we removed here the testing is the very first one, and then here remove 1, 2, 3, 4, and so on. So it seems like that we haven't tested the removing the tail one many times. So let's have some brief test over that. So remove. So after inserting, okay, we have slist A 1, 2, 3, 4, 5 is there. Then let's comment out this part for now. So here let's try to remove the very last one. So 0, 1, 2, 3, 4. Index 4 is the last one. And then since 1 has a removed index, 3 is also the last one. And then compile the program and run it. And here the error message is actually, it may be like that. So let's set breakpoint to see if a consecutive removal causes a problem or not. So step over. Okay, it's like that. So we have identified the cause of the error. Cause of the error is if we remove at the tail twice, we have such problem. So we got a hint. Now let's take a look at the code. There might be some logic error. So tail node, we need to find the left node. So what we did is there's something like we have slist, the node, and the like. So 0, 1, 2, 3. We want to find the left of the tail node. Then we move through the link this many times. So from 0 less than count minus 1 means total iteration is count minus 1 times we iterate. Since we have 4 data, count is 4 in this example, and the last position is a count minus 1. So this is a last position. So if you move through count minus 1, we are at the tail, not the left of the tail. So this loop iteration is actually not correct. We should have had minus 2 so that we get onto the left of the last one. So since count minus 1 is the last position, so we had a logic error. After correcting that, let's compile the program and then let's run it. No problem. So this error in implementing remove function caused such problem. So now this one works fine. We have tested the remove function. Also, we have fixed the bug. So you can now see the importance of testing, especially comprehensive testing is very important.